Hello, so we'll start the presentation. My name is Hugo Décharnes and I'm a senior design engineer at Syntacore. And today I will present you how easy it can be to remotely develop on an SCRx-based platform with our SDK. So Syntacore is a semiconductor IP company that has been a founding member and is a premier of the RISC-V Foundation. It has been developing RISC-V cores for more than 8 years and has a really wide range of IPs, so going from embedded class applications to application class cores. And today I will have made the presentation based on our SCR7, our second top core, which supports the full 64-bit ISA. Can be integrated as an 8-core on our platform and on top of our cache coherent, CHI compliant interconnect, and features all the necessary extensions to run a full-fledged operating system. So privilege modes, virtual memory support, advanced debugs, and all of that for a core that is outflow, dual issue, and also running at more than 1.5 gigahertz. So the platform I will have demonstrated will be an FPGA with 4 of these cores based again on top of our cache coherent interconnect. We'll have both Debian Linux kernel 5.14. All of that with 65 gigahertz, 4 gigabytes of RAM as a backup, and a 1 gigabyte Ethernet connection. And on that platform, and as well as my computer, local computer, I've installed our SDK. So what is Syntacore's SDK? It's basically a suite that is gathering all the necessary software that you need to develop, debug, and applications and run all operating systems. So that includes things like open things such as GCC, GNU Utils, NeoLib, GDB and GDB server, and OCDB. We also have emulators, so QEMU. And this package is available for Linux and Windows. So in today's demo, I will use the following software. I will use VS Code locally on my computer, and the Syntacore SDK that I've installed locally and also remotely. So I would have installed locally, remotely on the FPGA.
Here, I've connected 3SSH to the FPGA. As can be seen, I'm running a quad SCR7 configuration on top of a cache coherent memory subsystem. Currently, there is nothing in this directory. Let's go back to my VS Code and take a simple example. Here, I have a program that computes the factorial of a number and displays its result. Let's build it for my target quad-core SCR7. And now copy it to the FPGA. Here, I can run the program directly from here. And as can be seen, the result is incorrect. So I need to debug this application. However, this application is running on a remote device that is running an operating system completely different than the one I'm actually developing the application on, and a completely different ISA. But thanks to Syntacore's SDK, I have to my disposal all the necessary software to develop and to debug those programs as easily as if they were developed and debugged directly from the same personal computer. So for this, I will use GDB server. GDB server is basically your GDB, but crossed debugger, that is debugging from a different device. So let's launch GDB server on the FPGA. Now that it is launched, I can go back to my local VS Code, to the run and debug session, select launch GDB, and put a breakpoint, say here, and let's launch it. Okay, so now I can go into debug console, and I see I've hit the first breakpoint here. For the first iteration, I can see that the initial result is completely erroneous. And the reason being, variable hasn't been initialized. So now I can initialize. But in the same way as I would do if I was running that program on my local computer, I can also set directly the value of result. And continue. Now hitting the breakpoint second time for the second iteration, third iteration, and finally, the fourth one. Now program exited, and I can see that the value is not correct one. Here is something really powerful again happened. I've been running a program on my SCRx-based platform, that is, on the RISC-V based ISA CPUs from a computer that is here x86-64 based, with the exact same convenience as I would have had if I had debugged it, run it, debugged directly from that PC. So here is a simple example. I wanted to show you how easy it can be to develop and debug applications, even though those are on a completely different platform. Now let's take also another example to show you how powerful our CPUs are. Let's take this dining. Let's take a very simple, but still extremely CPU consuming dining philosopher example. Let's build it. And let's copy it to the FPGA. Okay. Now let's run the demo. Basically what it does is just implements the dining philosopher problem on a quad-core CPU-based Series 7. And we'll see the things a lot. Here we have multiple philosophers that are sharing, again, the forks. And all of that is working, again, on Series 7 based platforms with cache coherence.
Syntacore SDK gives you all the necessary tools to develop, debug applications, and run operating systems on your SCRx-based platforms. And all of that has been intensively tested, so you know it works. It's just plug and play for you. So now let's go back to the presentation. So in summary, what is Syntacore offering to you? It's offering high-quality RISC-V compatible IPs, so CPUs, but we have also developed, again, for our SCR7 and SCR9 CPUs, a cache-coherent CHI-compatible interconnect. We're giving you proven IPs. We're giving you SDK so that you can seamlessly do whatever you want with your platforms, whether it is FPGA-based or it is an ASIC. And we also provide customization possibilities for your core. So if you want some specific functionalities to be integrated, to be developed for your core, that is definitely something we can do for you and a big differentiator for us. If you want to get access to our IPs, know that SCR1, so our first CPU, is fully open. You can download it directly from GitHub, and you also have access to the SDK. So again, you can seamlessly use this platform. For SCR3 to 7, It is the full package is available after a simple evaluation agreement. To get it, you have to write to evaluation@syntacore.com. So thank you for your attendance.